finish up this question that we did last time. Hello, Kanya, welcome to Watobe. I'm going to finish off this question that we did in the last lesson that we had. All right. So it says here, if we've got the probability of A is 0,3, and the probability of B is 0,5, and the probability of A or B, that means both of them together, the union needs to equal 0,7, and I'm going to get to your entrance just now, Slay Queen, don't stress. Okay, is equal to 0,7. That means everything in these two circles must equal 0,7. And that is why in the middle of our circle, we have 0,1. The intersection is going to be 0,1, because if we add all three of these things together, 0.2, 0.1, 0.4, all of it together gives us 0.7. Now, just remind me again, Watobians, the probability of all events put together must equal how much? How much must all probabilities together equal? Beautiful, Retsepile, that's it. It must equal 1, right? So if the middle of it, if all of this is equal to 0.7, that means our 0.3 must sit outside of our circles. That means that this is the not part. This part over here is called the not. Ngazi, Teacher Nels is going to help you out real quick. Okay, so hold on to that. All right, Teacher Nelly is going to help you, don't stress. All right, so the first question says, find the probability of A and B. Who can remind us, what does and mean? Anybody remember and? In those fancy mathematical-ish terms, what does and mean? Good, it means both. It's the intersection, beautiful. So you must meet both criteria. So you must be in A and in B in order to qualify the intersection. Good, so the intersection is going to be the middle part, where both of them come together. So that is our intersection over there. So the probability of A and B is going to be 0,1. All right. Beautifully done, Ratsepile. Now let's look at B. B says the probability of not A. The probability of not A. Oh, my apologies. This is A and that is B. Okay, what do we call not again in probability-ish terms? Ooh, yeah, my English today is not doing the thing. Mfundo's like C. Mfundo remembers it starts with a C, can't remember the word itself. Good, well done, Amukelang. It's called the complement. Complement with an E, not with an I, because a compliment is when we're all like, oh, girl, you look so good. I know I do, thank you. Right, that is a compliment. But this is a complement with an E, which means the opposite of the thing that we want. So what we want is everything that is not in A. So this is everything that is in A. What is not in A, guys? What is not in A? Good, Unati, 4, and don't forget the other thing that's also not in there. What is also not in there? The 0,3 isn't in there either. So we need to add these two together, the 0,4 and the 0,3. So the complement of not A is going to be 0,7. Both of them together, the 0,4 and the 0,3. So all of them together. Well done, Pamela. That's it. Amogelang. Hello, DeAndre. I did read that right. Yes, it is. Hi, DeAndre. Oh, Oscar can't see. Okay. Oscar, Teacher Nelly is going to help you out very quickly. Hello, Princess. Amazing. Good to see you. All right. Let's talk about C, guys. Now, C says the probability of not A and B. Now, remember, guys, we said that A and B is equal to 0,1. So not A and B needs to be everything that is not 0,1. Here's 0,1. So how much is everything that is not 0,1? Okay. Oh, be careful, guys. Remember, the whole probability must equal 1. The whole probability must equal 1. Retsepile, you are on point. Nice, Jessica. Very well done, Mfundo. Now, if everything else is not 0,1, that's 0,2, 0,4, and 0,3. So we can go, instead of doing it the long way, we can say that the probability of not A and B is going to be 1 minus 0,1, which is then equal to 0,9. All right. And that's the answer we're looking for. Hi, Mfundo, no worries. Welcome. All right. Okay. Apiwe, what's up? Hi, Apiwe.
Ma'am, can I please, hi, ma'am. Can I please ask where did you get the numbers inside the Venn diagram?
Okay, so we've been given the numbers. Okay. It's just we did this question last on Monday. It was the last question we did, right? And we're looking at the probability of each of these. Now, here over here, they tell us that the probability of A is 0,3, right? So the probability of this part here is 0,3. The probability of A is 0,5. But because they both share an intersection, the whole of B must equal 0,5. That's why I've written 0,4 here and 0,1 in the middle. And the whole of B must be 0,3. That's why I've got 0,2 here and 0,1 in the middle. Am I making sense? Okay, because together they need to.
Thank you, ma'am.
If it's still a bit confusing for you, what I need you to do is go have a look at just the last 5 to 10 minutes of Monday's lesson. Okay.
Okay.
Just have a look at the
Thank
last
you.
5 minutes and you'll see how we got to this answer. Okay.
Thank you.
You're very welcome. Good. Okay, Abigail says, ma'am, please explain C. Okay, so look here, Abigail. In the first question, we found the intersection of A and B. We said that the intersection of A and B is 0,1. Now, we've all established that the probability of everything put together must equal 1. All of it must equal 1, right? So if we want the probability of not the intersection, that is everything except 0,1. So the way we're going to find everything except 0,1 is if we go 1 minus 0,1, which is equal to 0,9. Give me a thumbs up in the chat if that makes sense, guys. Especially Abigail, I want to make sure that you're with me. Thank you so much, Teacher Nels. Thank you. Somebody says, ma'am, when will we start doing finance? On Monday. We start finance on Monday. Beautiful. All right. Now, I want you guys to try this last one while I speak to Siamtanda. Look at not A or not B. Think about it very carefully, peeps. All right, Siamtanda, what's up?
Ma'am, I have a ask.
Yes.
So basically, when we try to solve for like, maybe for example, P not A, don't we say 1 minus PA?
Correct. Yes. Okay. But in this case, because we can see it, we don't have to do that. So we're going to say P of A complement is the same as 1 minus P of A. But we know what P of A is. The probability of A we've been given is 0,3. So we can say that's 1 minus 0,3. That's going to give us 0,7. Do you see how it's the same answer?
Yes, maybe we can also do that like with inverse. Maybe we're looking for P.
Absolutely. Especially if they haven't given you a Venn diagram. Okay. Especially if they haven't given you a Venn diagram, then you're definitely going to have to use the 1 minus. Okay.
Thank you, ma'am.
Good question. Very good question. I think a lot of teachers teach it that way. I'm just skipping the skipping the parts that make it a little bit more difficult. Matebele, what's up?
Hello, ma'am.
Hello, my sweetie.
Oh, my day.
Hello.
Hello.
I can hear you perfectly, my sweetie. Ask your question. Oh, no. Matebele's gone. Hi. Matebele, we can hear you, my sweetie. We can hear you perfectly. Okay, all right. Teacher Nels, I'm going to ask you to please just
hear me.
And just mute her for now and just ask her to type in the chat while I take Faith's question. All right. Before I take Faith's question, I'm going to just answer this question because we are going to run out of time, guys, and I want us to do quite a bit today. All right. So I know that not A is everything that's not in A, or B, or not in B. That's everything in here as well. Right. So the only thing that's left that's not in A or B is going to be everything outside. Correct, Ritapile, which means this part over here. 0,3. You guys are so smart. Just every day. Right. We know that the union of P, the probability of A or B is going to be 0,7. So not that is going to give us 1 minus 0,7, which is equal to 0,3. Okay. All right. Okay, guys. Today we're going to do a bit of probability analysis. We are not given Venn diagrams or any information really. We're going to have to figure out this information for ourselves. Okay. Everything else for ourselves. So I want you guys to read the scenario, read what they've written over here, and I want you guys to put together the questions that they've asked of you here. Okay, answer the questions as we go. Right, I'm going to give everybody 1 minute to read the question. When you're done, put a thumbs up in the chat for me, please. Once you've read the question, put a thumbs up in the chat. Caitlin says change. I'm not 100% sure what you mean, Caitlin. Please help me out and make it a little bit more obvious. Change the question. Oh, chance. Sorry. Yes. Sorry. Oh, yes. And I keep changing it and it just doesn't do the thing. This should be chance. Thanks, Caitlin. Good catch. Good catch. It should be chance. All right, excellent, excellent. All right, so I'm going to assume everybody's read the scenario right now. So we're going to continue with this question very quickly. Let's start here. It says here, a boy has a 0,19 probability of winning an art competition, a 0,13 probability of winning a talent competition where he will perform a song. Suppose he has a 0,11 chance of winning both the art competition and, what does this and tell us, peeps? This is the what? Good, it's both, it's the intersection. Beautiful. And so we know that there's an intersection somewhere where he could win both, right? He could win the talent competition and the art competition, right? Now it says, define the events. The boy wins the art competition. What is the probability of A going to be? It's in the question, guys. It's just a simple question, no trick questions. What is the probability that he could win the art competition? Good, Mfundo, that's it. 0.19. Now, the probability that he could win the talent competition is going to be 0.13. The probability that he could win P and T together, the intersection, is 0.11. Okay, good. Now, here's the next question. Are events A and T defined mutually exclusive? Are they mutually exclusive? Yes or no? And I want somebody to put their hand up and explain to us why we say no. Who knows? I know most of you guys know. I just need somebody to explain it to me. Ramorata, yay, love it. Hi, my sweetie, what's up? Give us the answer. Why? No, hello, my sweetie. Oh, lovely voice. Okay.
Thank you.
Why do we?
Because given they say that we have 0,11, which is both the T and the A, meaning that they intersect, and in mutually exclusive, they should never intersect.
Ah, beautifully said. I could never say it better. Right. If it was mutually exclusive, then the probability must have been 0 and not 0,11. Agreed?
Yes, ma'am.
Beautifully done. Like, mwah, excellent. Thank you so much. All the flowers, Ramorata. Well done.
Thank you, ma'am.
Lovely work. Lovely, lovely, lovely. Okay. Now, I want you guys to answer questions A and B here for me, please. Okay, it says, what is the probability that the boy does not win the art competition? Now, remember, not. Not is the complement. And Siamtanda put it so beautifully for us. The not will be 1 minus the probability of the thing actually happening. So give me the answer in the chat, peeps. Okay, I'm getting 3 different answers at the moment, and I need to figure out which one of these is correct. Okay, so we're going to look at that. Think of the question, guys. They're saying probability of the art competition, right? Or not the probability of the art competition. Good. So we're going to have, we know that the probability of winning the art competition is 0.19. So the probability of not is going to be 1 minus the probability of A, which is going to be 1 minus 0.19, which is equal to 0.81. Well done, guys. Okay, Panda. I wonder who Panda is. I've never seen this name before. Hi, Panda. Do you want to unmute for me?
Yeah, ma'am. Ma'am, I wanted to ask about like why do you -1? Like when you're trying to get the answer for like not.
Okay, remember the probability of everything put together needs to equal 1. Okay, so if we took 0.19 plus 0.7 plus 0, I don't even know how much is left. That is 89.11. If we add all of these up together, they must equal 1. So the probability of all the events happening at the same time must equal 1. So if the probability of A is 0.19, the probability of not A happening will be everything inside 1 except 0.19. So we can just minus 0.19 from the complete probability of 1. Am I making sense?
Yes, ma'am, you are. Thanks.
Good. You're very welcome. Good question. I just need to clarify that so that everybody understands. All of them, all of the probabilities put together make 1. So if we have a probability of not something, that's going to be 1 minus that thing that we want gone. Okay. Andre, I'm sorry, my sweetie. It's actually my fault. My screen has just told me that my internet connection is unstable. So if the things are not corresponding for you, it's on my side. Okay, I'm sorry about that. Teacher Nels, I think I'm going to switch my camera off for just a second until my network picks up. Okay, so you guys will be able to hear me. You just won't be able to see me. All right. Okay, excellent. All right, Oratile, what's up? Hi, Oratile. Oh no, okay. Hi, there we go. Hello, my sweetie, what's up?
Ma'am, I just wanted to ask about why do you always minus? I got the answer though. Why do you always minus with 1?
Okay, like we just said, Oratile, the probabilities of all of these things put together must equal 1. Okay, let's take that example that we had where we said the probability of heads, if we flip a coin, the probability of heads must be 1/2, right? And if we flip a coin, what is the probability of tails?
1/2.
1/2, good. So we know that any coin has 2 sides. So if I add up the 2 probabilities, I'm going to get 1/2 plus 1/2, which is how much?
1.
1, good. So now if I say to you, what is the probability of not heads? I'm going to take the probability of heads and I'm going to move it over to the other side. So I'm going to have 1 minus the probability of heads, which is going to give me 1/2. Okay.
Okay, thank you, ma'am. I understand now.
Beautifully, beautifully put. Okay, good question. Guys, please keep asking questions if you still have them. Don't stop asking questions. Okay, keep it up. I'm here to answer all of them. All right, let's talk about this last question over here. It says, what is the probability that he wins the art competition or the talent show? Now, we know that this is going to be an intersection. Oh, sorry, why am I saying the intersection? Sinako, hand up, please. Hand up. All right, it's the union, not the intersection, the union. Thank you, Ritsepile. It's the union. Okay, now, because we're looking for the union and we haven't been given a Venn diagram, we're going to have to use one of the rules that we learned. Guys, who can remind us, which rule do we use when we are calculating for the union? We've learned of 2 rules. What are those rules? Ramrata, do you remember? Which one are we going to use? Sinako, I'm going to take a question just now.
Ma'am, I'm not quite sure, but I remember that we're supposed to say P, A, or T equals to PA plus PT minus PA and T.
Oh, I couldn't have put it better myself. I could not have put it better myself. Do you remember what rule this is? What is the rule called? A and T. Do you remember what it's called? It's called the addition rule. It's called the addition rule. And you've just done it so beautifully. I mean, like, if I could switch my camera on, you'd see like the hugest smile on my face right now, because like, you just made my whole day. You made my whole day. Well done, Ramorata. Well done. Amazing. Very nicely done. Sure, guys, Ramorata's just be a Ramorata. Guys, seriously, just every day. It feels so weird to have my camera off, but it's perfectly fine. All right, I'm going to give everybody a chance to use this formula that we've got on the screen to calculate for the probability of A or B. I would like to remind you guys, the probability of A or T. I want to remind you guys, this is the probability of A, this is the probability of T, and this is the probability of A and T. So you've been given every single thing you need in the formula in order to answer the question. So all we're going to do is substitute, guys. Okay, give me your favorite emoji in the chat once you've got an answer for me. Actually, for the sake of time, pop the answer in the chat once you're done. While I speak to Sinako. Sinako, what's up?
I'm lost at question A.
Question A, which A? The first one that we did, this one down here. What is the probability that the boy does not? Okay, all right. Let me ask you a question. Let's say you're playing a soccer match, right? And you have the probability of you winning the soccer match is 0.4. What is the probability of you losing if the probability of winning is 0.4? Okay, remember both of these probabilities to 1. Okay. Are you there, Sinako?
You're gonna say one minus. Yes, I'm gonna say 1 minus 0.4.
Correct, 1 minus 0.4. So the probability of you losing is 0.6. Agreed. Good, okay. But here's another way for me to say the probability of losing. Instead of saying the probability of losing, I can say, what is the probability of you not winning? That's also going to be 0.6. Okay, so when we say not something, it's 1 minus the actual thing. All right, I hope that makes sense. Are we okay with this? Okay, you're breaking up a little bit, so I'm going to ask you to just give me a thumbs up in the chat, okay? Because I hear you, I'm hearing bits and pieces of your answer. All right, sorry about that, Sinako, because I can't hear you now and I don't know what to do. Okay, all right, Enke, what's up? Hi, Enke.
Ma'am, I wanted to ask if, hello, ma'am.
Hello.
Ma'am, I think that the next
I wanted to ask if, is it wrong to like, my volume is not voluming. Okay. Is it wrong to like ask if, if since we're using PA or T equals to PA plus PT minus PA and T? Is it wrong to use PA and T in case like they are common outcomes? Because then it will equal to 0, but like there are questions where you get confused and you end up using the wrong formula.
Okay, so we need to remember, Entle, that this particular addition rule is for a union. That this particular addition rule is for a union. Okay. It's only for union, and the other one is for intersection. The only for union, and the other one is for intersection. The is intersection specifically. Okay, so we need to learn the rule exactly the way that we see it, and not so much think, okay, but if I do it this way, this will happen. No, we use the rule exactly the way that we see it. Okay. All right, I hope I made sense. I just muted you because there's an echo. Okay. All right, I hope I made sense. I just muted you because there's an echo. Okay.
And your voice and video is not corresponding again, ma'am. But like, it's fine. I can still hear you. I'm not worrying about like your video or anything. Because like, I can still hear you. That's the important part. Like, I understand. It's just that my teacher didn't explain it properly, because there's this question with us. What is it? If PA equals to 0.25, PB equals to 0.5, and PA or B equals to 0.625, calculate PA and B. And then I used PA and B equals to 0, but then I was wrong. So like I had to use the formula which started with PA or B equals to PA plus PB minus PA and B. And then
Correct.
I got the answer then. So he didn't exactly explain.
Okay, I'm going to explain to you right now. Okay, so when we use the one where we just have PA plus PB without minusing this part over here, it's when our probability is mutually exclusive. So if it's mutually exclusive, of course, there's no intersection. So the intersection of both of them together must give us 0. And that's when we use that one, if it's mutually exclusive. Like, let's say, for instance, picking a red card and a blue card at the same time. That's never going to happen. So red and blue are mutually exclusive. When things are mutually exclusive, then we use this formula. But if there's an intersection, we can't use that formula because the intersection is going to be counted twice. That's why we need to minus over here. And I'm going to be very afraid to unmute you again because it's going to give us an echo. So if you could just give me a thumbs up in the chat, if that makes sense. Okay, just let me know if it makes sense. I know Ntagani points. It's giving echo, guys. It's giving echo. So I hope that makes sense, Enke. We only use the probability where P of A times P of B is equal to 0 when there's an intersection. Okay, I mean, sorry, when it's mutually exclusive. The answer we get for the intersection will always be nothing because the two circles in the Venn diagram don't touch. Then we use just this formula, P of A plus P of B. But if there's an intersection, we must add this part over here. I want everybody to give me a thumbs up if I'm making sense to everyone, not just Enke. Are you guys with me here? If the formulas are mutually exclusive, then we can just say P of A plus P of B, no problem. But if there's an intersection, to make sure that we don't count the intersection twice, we're going to add this part here at the end. Okay. Excellent. I'm glad everyone's with me. Teacher Nels, not you too. Okay. All right. Let's look at our next example. All right. I want you guys to have a look at this example over here. Right. Read through the example. Give me your favorite emoji in the chat once you're done reading. Okay. Just read the question. the whole question, even A and B. So you can kind of align your brain to what we're going to do next. Princess Haike. Thank you, Amgelag. Hi, Alicia. Alicia, I haven't seen or heard from you in a while. It's so good to have you. All right, peeps. Okay, let's get started with this particular question. All right. Lovely emoji, Pavani. I love it. Okay. Stinisako 2, where have you been? Where have you been, Stinisako? It's been a while. It's been a very long while. All right, let's get started on this question here, guys. All right, a spinner in a game has 3 sections of equal size that are colored red, blue, and green. So we're going to draw the spinner real quickly, and I'm going to show you what it actually looks like. So it's a square, and I'm drawing a circle, but I'm saying square. It's a circular spinner, right? And it's split up into 3 parts. And again, Watobians, please, no judging ma'am's drawing. We all know how this is going to go. Okay. There's the green part. Okay, and then we're gonna draw the blue part. Hi, princess. Thank you, Jessica. Yes, guys, don't judge. And the blue part and the red part. And we're going to, because Teacher Coco is not good at measurements or drawing, we're going to assume that they're all the same size. Okay, we're going to assume that they're all the same size. Okay, now it says, okay, we're going to name each of the events. We're going to name the green part G, and we're going to the red part R, and we're going to name the blue part blue. Now, here's my question. Are these events independent? Yes or no? Are they independent? Keegan says no. Naledi says maybe. Kahelelo also says no. Stephen says no. I want you guys to think about it. Don't just write no because everybody else is writing no. Refilwe says yes. Blessing, that's an honest answer. I'm not sure. I'm not sure. Eliche says yes. Jessica says yes. Keegan says yes with a question mark because Keegan said no before. Princess, I don't know, is fine. Somebody said da. I see people speaking Russian up in here. Angazi Zain, that's such like fair. All right, let me ask the question this way, right? If I take the spinner, and I spin it like and it lands on green, the probability of green is going to be 1/3. Now, if I spin it again, did green disappear? Did the green part disappear if I spin again? No. So does the second roll or the second spin depend on the first spin? No, it doesn't, which means they are independent events because the first spin has nothing to do with the second spin. So here's my question again. Are these events independent? Yes, they are independent because the first spin is not affected, or the second spin is not affected by the first spin. Give me a thumbs up if I'm making sense. I want everybody to be on the no worries, Slay Queen. Good. I'm glad I'm making sense. I'm left and then, okay, cool. All right. So I'm glad we're all on the same page. So are these events independent? Yes. And because when I spin the first time, probability the same. Spin the second time, probability the same. Nothing has changed. Okay, nothing has changed at all. All right. I don't know, the Amuhelang who put their hand up, I don't know how to answer that question. Okay. True, Keegan. It's always the questions like this in the exam that get you. All right, but think about it practically. Think about it practically. All right, let's answer this question. All right, find the probability that when the spinner is spun 2 times, twice, the following outcomes are obtained. So what would happen if I spin the spinner, if I spin the little hand and it lands on red both times? So we're going to look for the probability of red and then the probability of red. Now, be very careful, Keegan. Don't just say that, because we're not actually adding. We're talking about dependence and independence. We must use the product rule. We're looking for the product rule. Okay, because we're talking about dependence and independence, we must use the product rule. Now, I want you guys to think about this. What is the probability of it landing on red the first time? Let's start with just the first one. What is the probability of the first land on red? Good, Jessica, that's it, Caitlin. First land on red will be 1/3. What is the probability of it landing on red again? 1/3. Good. Now, what is the probability of getting red and then red? Now, we can't add them because we're talking about dependence. We must multiply. So I'm going to get 1/3 times 1/3, which is going to give us how much? Beautiful, Anotida. That's the answer I'm looking for. That's it, Enke. 1/9. All right, beautiful. Now, with
Can you guys hear Teacher Coco? We can't hear you. You're muted.
Can you hear me now?
Yes.
Oh, okay. Sorry. Sorry, I don't know what happened. I do not know what happened. Okay, all right, excellent. Okay, so let's look at the other two. All right, so it says, what is the probability of red? We already know that's 1/3. And the probability of green. What's the probability of landing on green, guys? 1/3, good. Now, we want the probability of red and then green. Rulani saying, ma'am, what if you use a tree diagram? Absolutely, you can. Okay, the reason why I haven't included tree diagrams is because they're not part of grade 10 CAPS. But if your school has actually already done the tree diagram, absolutely, use the tree diagram. However, I'm following the CAPS document and I'm following the annual teaching plan. If it's not there, then I can't help. Okay, I can't. Guys, remember, we're just multiplying. All right, just the multiplication. So we're going to go 1/3 times 1/3. Okay, give me the answer there. Slate Queen, what's up?
Hi, ma'am. Is there anything new that I missed?
No.
So it's still the same word.
Hold on, because I've got a gift for you after the question. Okay.
A gift? I love gifts. Oh my gosh.
It's a maths gift. It's a maths gift. So hold your horses before you're like, gift. Okay. The math related gift.
That's so sad.
It's a good thing. Say, yay, man, thank you so much. Right? No,
inside I'm just feeling very sad. Just very sad.
I'm sorry. I'm sorry.
Let me just
I'm sorry.
Because I'm pretty sure. Just like
what we're gonna do. Okay, what we're gonna do. All right, peeps. Okay, last question says both are the same color. So we already know what the probability of. Okay. Whew.
Teacher Coco, now we can't hear you at all. Okay, we can't hear you.
Hello.
There.
Hello.
Now we can hear you.
Oh, okay. I don't know. My external webcam is doing funny things. So yeah, who said KFC Wi-Fi? You guys are not, no. You can't be those people, right? Okay. So we already know that if I get the probability of red and then red, probability will be 1/9. Now, if I get the probability of blue and then blue, what's the probability of blue and then blue, guys? What's that going to be? Correct. It's going to be 1/9 again. Right. Now, again, if I ask for the probability of green and then green, it's going to give me 1/9. Good. Excellent. So all of these probabilities are going to give us 1/9. All right. Give me a thumbs up if everybody's okay with how we've answered this question. Thank you, Naledi. That's it, Tuniseko. Good. Excellent, excellent, excellent. Good. Keegan, we do not add, we multiply. Okay. Excellent. Okay, I saw somebody with a thumbs down. If I've lost you, is it Remy or is it, I hope I pronounced that correctly. Is it Remy? Remy, you need to explain to me where I've lost you so we can hold on to that. Just specifically, this particular question is specifically for slavery. Okay. And the reason I'm saying it's specifically for slavery is because she sent me a question via email the other day. Okay. She sent me a question via email the other day, and she sent me the memo. And the Venn diagram that she sent me in that memo looked kind of funny. So I did a little bit of research and I found the question. So we're going to go through this question together. And please, guys, don't listen to Inako. It's not difficult at all. We're going to take it a step at a time together. Okay. If you are up for the challenge, give me your favorite emoji in the chat. Let's see. How many of you guys are with me? Let's do it. Yes, Pile. I love to see it. Oh. Keegan, no, not Keegan. Who said Amogalang? It is grade 10. It's taken out of the grade 10 textbook. Okay, and yet don't even stress. We're going to do this very slowly. As you can see, there's a lot of steps involved, but it's because all the steps lead up to the thing that we need. And Keegan, no, you're not allowed to do that. Nobody's allowed to give up. All right, let's start at the beginning. It says here, a dice is rolled. A dice is rolled. There we go. Dice is rolled. List the samples. List the samples. Like me. Let's start from the beginning. What is our sample?
Our samples. Oh my gosh! Wait, a dice is rolled. List the sample space. Wouldn't it be 6 or 12?
Not 12. How many sides are we going to get? What are the possible outcomes? I could possibly roll a 1 or
a 2 or a 3 or a 4 or 5 or 6.
Beautiful. Good. We're off to a great start. Okay.
Okay.
Now, don't go through the next one. It says, use set notation, which I just used. This is set notation, what we've done here. Okay. It says, use set notation to describe the event E of obtaining an even number. So we're going to write it like this. We're going to go E is equal to, now, from our sample space, which are the even numbers that we can get from our sample?
2, 4, and 6.
Beautiful. So we're going to write 2, 4, and 6. Excellent. Done. Next question. Use set notation. Again, set notation to describe the event O. So how am I going to start writing the set notation for the event O of obtaining odd numbers?
O is equal to, O is equal to, right. Then it's that weird bracket. Then after that, you'd say 1, 3, 5.
Beautifully done. And then close the bracket. Good. Yes, now it says, represent the event, okay, of obtaining a factor of 6 in set notation. Again, set notation. How are we going to start?
F equal,
F equals,
open bracket. I'm not sure if you'd say 1 or you'd like, oh, no, lady, I'm
Yes,
guessing.
what
No,
is the
1, 2, 6.
1,
1, 2,
1,
6.
2. Ah,
Oh,
there's
3,
one
6.
missing.
3, 6.
3 and 6. Okay. Beautiful. Done. Okay. So we're off to a great start. You see how easy the stuff is? Quite easy. For
Yes, ma'am.
okay. All right.
Mm.
Let's do the next. Now it says represent the event F. What does this funky looking sign over here mean?
It's not complement, ma'am.
Hmm?
Union.
Look at it. Like that. So,
Union.
yes,
Union.
it's the union, right? And we want to express it in certain occasion as well. So we're going to go F union E. Now remember, F union E means everything inside F and E in both of them, right? So we're going to look at our set F and set
Okay.
E. We need to express everything at least once. Okay, so give us all the
So,
numbers.
1, 2, 3, 4, 6.
1, 2, 3, 4. Excellent. Good. That's the union. Everything in both of them. Now the next one says
Yeah.
represent the event F. What is this sign now?
Complement.
Mm, 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 mm.
And,
What is the complement? Union. This one is
and.
Good.
I said and, ma'am.
Okay, intersection. Good. And beautiful. Right. So we're going to go F intersection E. Now,
Weird
remember the
bracket.
intersection must be both of them. Must be in both of them. So which number is in both of them? In both F and G.
2 and 6.
Beautiful. Good. 2 and 6. Excellently done. Good. Now we're almost at the end of the sum. We've done all 6 questions right now, and with it. Right. Now,
Yeah.
this N over here tells us that we need to count how many things are in each one. Right. So we want the number of elements in our sample space. Let's go count. How many elements do we have in our sample space?
6.
Correct. 6. Beautiful. Good. How many elements do we have in E, in event E?
3.
Good. 3. Elements in event O?
3.
Elements in event F?
4.
Beautiful. 4. Okay. Now, elements in event F union with O. Now, we don't have O, so you're going to have to go back and count. Okay. So we can then look for F union with O, right? It's going to be everything in this.
Oh, the chats are blocking me. Wait, okay, yeah. Sorry, continue.
All right. So what are the elements in there?
F union E is 5.
No, union is all of them together. We're going to have 1 and 2
3
and
2
and
3 6.
Missed 1.
5
and
4 6.
This 6. Correct. Okay. Right. So what is the number? How many of them are in there? So it's a learning curve. How many of them are in there?
There's
1,
5 of
2,
them.
3, 4. 5 of them. Good. So how many elements are in there? 5. It says F intersection with O. So we only want things that are in both. Which numbers are in both F intersection?
1, 3, 1 and 3, sorry. Just 1 and 3.
1 and 3. So how many elements do we have?
We only have 2.
Now the only thing left is the Venn diagram. Fortunately, feel like we're out of time. Teacher, now I'm going to ask you the question as I'm doing what I'm doing now. Okay. So do you agree with me? We've got many intersections here, right?
Yes,
First
we do.
we know that our sample space is the rectangle. That means how many circles do we need to have in the middle?
Just 1.
E is going to be a circle. What else is going to be a
Oh, and
circle?
O is going to be a circle. Sorry, I thought you were asking like in the middle, like in the middle.
Okay, good. And what else is also going to be a circle?
F.
Correct. So we're going to have E, O, and F. Yes, please, teacher Nels, if you could just jump onto the other piece. Okay, let us know. All right, cool. So I'm going to draw 2 circles. Let's do 3 circles. Thank you, teacher Nelly. Okay, 3 circles. I think he's been doing this lately. It's been really long. Okay. No judgment of my circle. Here we go. No, don't judge my circle. How?
I'm not. I need the help right now, so there's no room for judgment.
No, I hear you laughing. Okay, so let me just ask again, quickly, Slapey. These parts where these meet, right? These parts where these meet. What's it called? What's that part?
Intersections.
Correct. All right. And for some reason, my computer is just not cooperating with me. So I don't know what I'm doing. Okay, good. So let's go find the intersections of each of these. They're going to be 2 intersections, right? We're going to have the intersection of F, intersection with E, and we have those numbers. The intersection of F with E is 2 and 6. 2 and 6. Intersection of F with O is 1
and 3.
Right. Okay, let me just see if my work. All right. So if we name these, we're going to name them E, F, and O. Why would I put F in the middle? What do you think, Slate?
Because it's our sample space.
Well, it's not really a sample space, but it has both of the things that
empty,
we need,
yes,
right?
ma'am, that empty space that we put all the random numbers in.
Correct. Good. Because F has an intersection with E and it has an intersection with O, it makes sense that I would put it in the middle. Okay.
Yeah.
So now, what is the intersection of E and O? That's going to be 2
and 6.
Right? The intersection of F and O is 1
and 3.
Okay, good. But now other numbers are missing. Let's go have a look at E. What's missing in E? We've got 4 and 6.
2, 4,
We've already
6.
accounted for 2 and 6. So what's missing in E? Here's Jessica. What's missing in E?
2, 4, 6. No, sorry.
Right.
4. 4.
2 and 6.
It's
so
4.
4 is missing. Good.
So
4 is missing. What about in O? What is missing in O? O is 1, 3, and 5.
3. It's sorry, 5. Ooh, 5.
Correct. Is there anything else that we've left out? Anything else that we've left out?
We've left out F.
I mean numbers wise. Anything else that we've left out?
I don't think so. Isn't it going to be 0?
Oh, there's 1. All of them. Why does E and O not intersect? Why did you not make E and O intersect?
Yeah. Isn't it because they have like a common, what's the circle quadrant thing?
Do they have a common circle? Even and odd numbers.
Oh.
Do they have anything in common?
Yes, ma'am. Yes, they don't. They don't.
No, they don't. So we call them what? Mu, 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 mu. With an M.
I don't want to lie to you. I don't know. I really don't know.
It's in the chat. It's in the chat.
Mutually exclusive. Yes.
Good. Because you can't have an even and an odd number
together.
Okay.
Yeah.
And that's why E and O don't have. They are only joined together by F. Okay.
So, ma'am, in the F, couldn't you put a 0 in there? Because it's most a neutral number.
No, we can't. No, because our sample space doesn't include 0. Our sample space is only 1.
Okay, perfect.